What is probability? Episode 1, The Basics. Illustrated and narrated by Isa. What is probability? Now, most people think they completely understand probability. Probability has to do with a flip of the coin, or drawing cards, or maybe even the rolling of a die. But what is it really? Probability actually is a little bit more complicated than that. We start with a population. This is a population of people or a population of objects. It's just a large group. And from this population, we randomly take pieces, and we collect these pieces together to get a sample. The probability is then, what is the chance that what we want from the population ends up in the sample? So if we take something as simple as flipping a coin, the population of a coin is fairly simple. The population is either heads or tails. Those are the only two things that can possibly happen when you're flipping a coin. So when I want to take a sample, this is my sample space. I can either sample and get heads or have a sample that gets tails. About half the time when I randomly select something from a coin, the probability that my sample is just the head is 1/2. And the probability that I get tails from my sample is also 1/2. Things get a little bit more complicated, however, when we're doing cards in a deck or something much bigger. In this case, my sample space is the whole 52 cards in the deck. This gets complicated, and it has a lot of questions and different types of questions that we can ask. For instance, we've got a deck of cards, and in that gray deck of cards lies every one of my 52 cards. What happens if I take out a card and it happens to be the 6 of spades? That's a beautiful card. I now put it back into the deck. What's the chance that in that population, that deck population, when I randomly select a sample, I've shuffled up the population, I'm going to randomly select a sample, what's the probability that I get that 6 of spades again? That is called AND, or intersection, because when I pull out that sample, it needs to be a 6 and it needs to be a spade. If I pull out the 6 of hearts, that's not the card that I want. If I pull out the 10 of spades, that's also not the card that I want. And has a very specific meaning here. It needs to be a 6 and it has to be a spade. In this case, it's only 1 out of 52 cards. That's the probability that when I take a sample, I get the 6 and spade. What happens if we're playing crazy eights? If we're playing crazy eights and the 6 of spades is drawn and put on the table, and then one card is dealt to me, what's the probability that I can play that card on the 6 of spades? Well, this has changed greatly. Now for my mystery card, I can use any of the spades. Any of the spades would allow me to play on the 6 of spades, or any of the 6s. This is where or union comes in, and it's very different from and. Although in English sometimes we use or and interchangeably, in probability we can't. Or means either or. I can have a spade, I can have a 6, doesn't matter which, I can have all of them. Or means that my probability has now shot up to 16 over 52. Not just the 1 over 52 of the 6 and the spade. So now that we've talked about and or, I want to talk about given or conditions, because sometimes conditions hold. Sometimes we know certain things about the card. Like in this instance, it can't be the 6 of spades. Why can my question mark not be the 6 of spades? Because that's already on the table. So we can cross that out of my sample space. It's not possible that my sample question mark is the 6 of spades because it's already there, which means my probability isn't truly a 16 out of 52. It's actually 15 out of 51. So be very careful with given and conditions. Now, say I draw a card and I want what is the probability it is a diamond and an 8. A diamond and an 8 means only one card, so 1 out of 52. What is the probability is a diamond or an 8? Diamond or an 8 means the 16 out of 52. So we've noticed how radically different and or can be in probability. The reason why we call and intersection is because if you look at what's highlighted in my sample space, the diamond and an 8, the 8 of diamonds, that's located at the intersection of street 8 and street diamond. If we look at those as two streets, they intersect at that one specific place. So sometimes it's called and, sometimes it's called intersection. Or is sometimes called union. And this is because a union is an entire group of things. Like the union of the states in the American Civil War. The Union wanted all the states to stay together. So the state of diamonds and the states that are 8s are all together and included in my probability. Things can sometimes get a little bit more tricky when I have something like this. I've got my population and I've pulled out my sample question mark. What is the probability that in my sample it is a diamond and a spade? Well, my sample is only one card, and there is nothing in the entire deck that is both a diamond and a spade. That's impossible. That's 0 cards out of 52. If you're looking for a diamond and a spade, there's something wrong with you. That doesn't exist. You clearly have no idea what a card is. This is called mutually exclusive. Mutually exclusive is when one happens, the other cannot happen. And it drastically changes our probabilities for and. It also changes our probabilities for or. What is the probability it is a diamond or a spade? In this case, diamond and spade are mutually exclusive, so they don't intersect. Or then means it's a lot higher probability because we count up all the diamonds and add up all the spades on top of them. We don't have to worry about double counting the intersection or worrying about which cards need to be in there. That has leapt to half the deck. So mutually exclusive events drastically change the probability. It can either lower it in the case of and or raise it in the case of or. Okay, we've got the population, we take out the sample. What is the probability is an 8 given it is a diamond? Alright, in this case, given it is a diamond. We know it is a diamond. We want what is the probability is an 8. For some reason, we know that it's a diamond. Perhaps only the cards that are left in my population are diamonds. Or perhaps someone's already taken a look at our sample and have given us a hint that it's a diamond. In this case, the probability that is an 8, given we know it is already a diamond, is 1 out of the 13 diamonds. 1/8 out of the 13 diamonds. Notice, if our condition changes, our probability changes. These two questions are almost exactly the same. Only the second question asks, what is the probability it is a diamond given it is an 8? In this case, we know it's an 8, and we want to know the probability it's a diamond. In this case, we are given it is an 8, which means there are only 4 possible cards that our sample can come from. So because there are only 4 possible cards for our sample, and only one of them is a diamond, we have now jumped from a 13th to a 4th, which is far more likely. These are called conditions, and you have to be very careful when a condition is tacked on to your probability. Normally, our probabilities are whatever out of the whole. So normally our bottom number, our denominator, is always going to be 52. But when you have a condition, that bottom number can change. Okay, we've got a population, we've got a sample. What is the probability it is at least an 8? Wording can become tricky, particularly when your sample or population is numbered. When things are numbered, then we can talk about at least, at most, greater than or equal to, less than or equal to, smaller than, bigger than. These are all very complicated words because they mean very different things, but so similar in the real world. Now, what is the probability of at least an 8? Well, if something costs at least $8, that means $8 or more. So in this case, we're going to be looking at the 24 out of 52 cards. And this is very different from what is the probability it is higher than an 8. If it has to be higher than an 8, notice the 8 column no longer applies. So my probability goes down to only 20 out of 52. Same thing happens when we've got a population, we pull a sample, and it talks about at most an 8. If it costs at most $8, 8 is the most it can be. So in this case, it's 32 out of 52. What is the probability that it's lower than an 8? Lower than an 8 means it can't include 8, which means we're down to 28 out of 52. So we've got a population, we pull out a sample. What happens if our sample has 2 cards in it? Well, this just completely changed everything and requires a completely new episode. So join us next time for an episode on what happens when we draw 2 cards to be part of our sample. The end.